Hello guys, I am Nidhi S. Bagalwadi, your science teacher, Sankalp Learning Solutions. In the last class, we learned regarding the potential difference, the inner meaning, the depth knowledge regarding the potential difference, and also we discussed regarding the textbook definition of the potential difference. Today we are going to study a lot regarding the potential difference. Okay, as I said in a previous session, the potential difference is defined as the work done in carrying the electric charges, especially the electrons, from one point of a battery to the other point of a battery is called as potential difference. Okay, so it is measured, or it is nothing but the work done in a force into displacement we run, right? The force into displacement, how the movement of electrons takes place. So that gives us the potential difference. In a common terms, what I said, the electric charge difference between two ends of a battery, that is a positive and the negative terminal of a battery, is regarded as potential difference. Now let us try to see the formula. Let us try to understand the formula which gives us the potential difference. So the potential difference is also called as voltage, we know that, and the voltage is represented by V. So voltage is equal to the work done, okay, the work done upon the charges carried. How many charges carried? Okay, now so voltage is represented by the capital letter V, or higher case V, then is equal to higher case, that is capital letter W, and charge is represented by Q. The charge is represented by lower case q, otherwise the higher case, that is a capital letter Q. So this is regarding the equation or the formula to find the potential difference. V is potential difference or the voltage, W is work done, and Q is the charges. Okay. Now let us try to see or try to get the SI unit of potential difference. So SI unit, what is this SI unit? It is the well-known standard unit about some quantity in the whole world. So this SI unit will be same in the whole world for a definite quantity. Okay, so SI, system internationally. Then SI unit of potential difference. Okay, let us see. So we know that the equation is W divided by Q. What is the SI unit of work done? It is measured in terms of joules. Okay. Then what is the SI unit of charge? It is measured in terms of coulombs. Okay. Then overall, what is the SI unit of potential difference? That is voltage. It is joules per coulomb, or we can write symbolically as J. Joules is represented as capital J by C. Capital letter C is the representation of the coulomb. Okay, joule per coulomb, or we can write like this, J C raised to minus 1. So this is the SI unit of voltage. Now, a scientist named Alexander Volta, okay, studied a lot about the potential difference. Okay, studied a lot or discovered a lot about potential difference. In the memory of him, to respect his discovery, to respect his studies, we will also keep, or we will also consider volts as a SI unit of the voltage or potential difference. So I can say 1 joule per coulomb is equal to 1 volt. So how you define 1 volt? 1 volt is nothing but the potential difference we will get when 1 joule of work is done to carry 1 coulomb of charge from one point of a battery to other point. So what is 1 volt? The potential difference formed, okay, or produced when 1 coulomb of charge, the work done to carry 1 coulomb of charge from one point of a battery to the other point of a battery. So that is nothing but 1 volt. 1 volt will always be equal to 1 joule per coulomb. So how can we write 1 volt? 1 volt will be equal to 1 joule divided by 1 coulomb. So by this we can define the definition of 1 volt. 1 volt is defined as the potential difference which is produced when 1 joule of work is done to carry 1 coulomb of charge from one terminal of a battery to other terminal of a battery. This is regarding the definition of 1 volt. Okay. So the SI unit of potential difference or voltage will be volts, or we can say joule per coulomb. Okay. Now, fine. Let us consider, here I have a battery which is used for the remote, especially the AC remotes and the TV remotes. Whichever battery you see, this is a cell actually, this is not a battery. The number of cells form a battery. So whichever cell or a battery you see, they will be giving potential difference on it. That is, here we can see the potential difference is, just a minute. Here we can see the potential difference. I think it is very smallly written. I don't know whether you can able to see it or no. So you observe in your TV remotes or the cells which are used for your wall clocks. Okay. So on it they will clearly mention the volt, that is 1.5 volt. On this battery I have a reading that is 1.5 volt. Okay. So what is this 1.5 volt is? So I can say 1.5 joules divided by 1 coulomb. Then how I will define this? 1 point, that is the work done to carry 1 coulomb of charge. 1.5 joules of work will be done by this shell, okay, by this shell to carry 1 coulomb of charge produces the potential difference of 1.5 volt. So here that force will be there, no, inside the battery that force will be there. Okay, so that force will be the reason for the displacement of the electron, for the movement of the electron. So that force or energy is nothing but the work done. So that work done will be 1.5 joules only. So the work done to carry 1 coulomb of charge, okay, inside the battery, to carry 1 coulomb of a charge from one point to another point gives us the potential difference of 1.5 volt. Let us take 9 volt. So what is this 9 volt? That is 9 joules of work is done to carry 1 coulomb of charge from one terminal of a battery to other terminal. So these are the examples how we have to define the volts. Now, so in all our houses we can find the mains. So from which the other connections of wires will be connected, that is the lights, fans are connected to that mains only. So whenever there is a power cut, you will see that mains. When the light is not there in the mains, you will get to know the power had been cut. There is no power. So that mains will be having the voltage around 220 volt. So in India we have 220 volt. Okay, 220 volt for the mains for each and every house in India. So what is this 220 volt? 220 joules of work will be done to carry 1 coulomb of charge from one point of a battery to other point. So from this 220 volt only we will be managing the fans, tube lights, even though the refrigerators, then washing machines. So every electrical appliance in our home will be run by this 220 volts only. Okay, please keep it in mind. It is a general knowledge question. So we have 220 volt in India for the mains of our electric current. Okay, now this is regarding the SI unit. then the definition of 1 old, and also how to define the number of olds. How we will get to know or understand the daily examples which will be having the label as olds. Okay. Now, let us study certain numericals based on the potential difference. The first numerical is how much potential difference will be there for 3 coulomb of charge, 3 coulomb of charge when work done to carry it will be 90 joules. Will be 90 joules. This is a short answer questions. So here first, whenever they will be given numericals, we have to write first given. What is given in the problem? The first one is 3 coulomb. So what is this 3 coulomb? By understanding the SI unit only, we will get to know the 3 coulomb is nothing but the charge. So Q we can write it as 3 coulomb. Next, when work done to carry it, already it is mentioned directly, work done is 90 joules. So work done is represented by W, 90 joules. Then what we have to find? The second step, potential difference. It is represented by capital letter V. Then solution. The first thing you have to write is the formula, because the marks will be allotted for the formulas also. So work done divided by charges. So work done is 90 joules. Okay. Then the charge is 3 coulomb. So we will get 30 joule per coulomb, or we can write 30 old. So the potential difference will be 30 old for this 3 coulomb of charge which is carried when the work done will be 90 joules. So like this you will get many other problems related where you have to find the work done, where you have to find the charge when any other 2 quantities will be given. So we will be solving 2 or 3 more problems in the upcoming session. Until that, have a nice day.